Just for clarification, I'm editing this in, is all the integral questions, if you're coming to watch for the integral questions, are solved in the end. After about an hour or 45 minutes into the record, I don't know, but they're solved later in the video. Okay, so I first solved the partial fractions and then I solved the integral questions. Welcome to chapter 8.2 math. Welcome to partial fraction decomposition. So I'm gonna explain before I start, but basically, get this out of my face. Partial fraction decomposition. Okay, so just to make sure my mic is on. Okay, in math, you can split up two fractions. The first thing I'm gonna ask you to do is, let's say I want to add this fraction, 1 over x plus 1 plus 1 over x minus 1. How would you add this? How would you add these two fractions? You would multiply by the common denominator, right? Up and down, right? So x minus 1, and you're gonna get over here x minus 1 plus x plus 1, which is 2x over x plus 1, x minus 1. So as you can see here, two fractions became 1. Now, what if I took this and I came and told you, okay, I want to split this up into two fractions. So I want to go the other way around. Let's say I don't have this. Okay, let's say you don't have any of this, but you want to go and you now want to split this up into two fractions. Okay, so just so I can visualize how that's going to go on, let's take a look at the two fractions that led us to this big one fraction. Over here, you had the denominator x plus 1, and over here you had the denominator x minus 1. As you can see, at the full denominator, you have x plus 1 and x minus 1. So the first thing when you want to split a fraction is look at your denominator. Okay, look at the denominator and factor fully. As you can see here, our denominator is factored fully, but sometimes you're gonna see it like this. If I were to simplify this as much as possible, I would expand these, and you're gonna have x squared minus 1. So if you would want to split, the first thing you do is what? You look at the denominator, it has to be factored. In this case, it's not factored. So I would have to factor it. X squared minus 1 is what? It's just x minus 1, x plus 1. Alright, so perfect, you factored fully. Now, what do you want to do? You want to split it now into two fractions. Okay? It doesn't have to be 2, it can be 3, 4, 5, depending on how many factors you have at the bottom. In this case, how many factors do I have? I have x minus 1, then I have x plus 1. So, if I want to split this, 2x over x minus 1, x plus 1, I'm going to split it into two fractions. We're going to say something over x minus 1 and something over x plus 1, right? We're splitting it into factors. Now, in math, what we do is we call this here a and we call this here b. Okay? So, there you go. We did our first step. We looked at the denominator, we factored it fully. The next thing we did was split it into two fractions. A over first factor, b over second factor. Okay, now, we know that when you add these two fractions, the numerator is going to end up like the original numerator, right? So when we add these two fractions, we know that the numerator here is going to end up like the first fraction, right? Okay, so imagine we're trying to add these. Forget about the first fraction. Imagine we're trying to add these two fractions. What would I do? Obviously, I'd multiply by x plus 1 here and multiply by x minus 1 here. So my new numerator is going to be ax plus 1 plus b x minus 1 over the denominator here, x minus 1, x plus 1. So as you can see here, we have this numerator, and we know that somehow this numerator should be equal to the original numerator. So I can write now that ax plus 1 plus bx minus 1 is equal to 2x. You get this equation. Okay, perfect. Now, what do you do here? We need to figure out what a is, and we need to figure out what b is. How do you do that? This is where the third step comes in, and it's called substitute the roots. So I have two unknowns here, a and b. So I can't solve if I have two unknowns. So I'm going to start substituting some x values so that I can take out one of these unknowns. So to take out an unknown, I would want to make this x minus 1 0. So when I multiply that 0 by the b goes. وخلاص, I'm only left with a. Right? So basically, the third step to substitute the roots is check the roots of each one. What's the root of x plus 1? Negative 1. Right? So let's first substitute negative 1. A into negative 1 plus 1 plus b into negative 1 minus 1 equals 2 times x, which is what? Negative 1, as we said. This is 0. So as you can see, just like that, we got the a cancelled out. So negative 2b is equal to negative 2. So basically b is equal to 1. So we found our b value. Now, to find a, you can just substitute b back in, or we can now, instead of substituting this root, we can now substitute the root of this one. What's the root of x minus 1? It's 1, right? So let's substitute our 1 into here. So a into 1 plus 1 plus b into 1 minus 1 equals 2 times 1. As you can see here, this gets cancelled because it's 0. 1 minus 1, 0. So you're going to get 2a is equal to 2. So therefore, a is also equal to 1. So as you can see here, we now know our a value and we know our b value. And you can now substitute this back into our partial fraction. So 2x over x minus 1, x plus 1, which was, this was our original fraction. We can split it into a over the first factor plus b over the second factor. We found out that a and b are both 1, so we can say that it's 1 over x minus 1 plus 1 over x plus 1. Perfect. Just like that, you just split your fraction into two smaller fractions, partial fractions. That's what we call it. Okay, so is it long? Yes, but I just explained this. That's why it's long. So let's summarize our steps. The first thing, it's factor your denominator. Okay. Second thing is split into n fractions. It goes on for as many factors as you have. مثلا, if I had here x squared x plus 1 as my denominator, if my denominator is x squared x plus 1, how many factors do I have? I have 3 factors. Some people will say this is 2 factors. Why is it 3? Because x squared is x times x plus 1. Okay, so I would split it into a over x plus b over x plus c over x plus 1. Okay? Sorry, it's not b over x. It's a over x, then b over x squared, then c over x plus 1. Because you go up with it. Okay? First factor, second factor, third factor. Okay? Anyways, you're going to see, when we solve, you're going to see. Let's go back to our steps. So, split into n fractions. We don't know how many that n is. So, a over n1 plus b over n2 plus c over n3, and so on and so forth. Third step is substitute your roots. Okay, very easy. It's not hard, wallah. It's just these 3 steps. Okay, but before you substitute your roots, you need to form the equation. We can call this 2.5. Form your equation. Form the equation. The equation is what we wrote here. Okay, the equation is very, very easy. Okay, you will be very fast at it. Okay, I'm gonna show you. It's so easy to solve. So I'm not gonna integrate. I'll leave the integrals till the end. First, I just want to find the partial fractions. Okay, so let's start here. Okay, 10x plus 8 over x plus 2 squared. Type. Let's take a look at our denominator. Is it factored fully? Yes, x plus 2 squared. Now, what does that mean? How many roots do I have? I have 3. 1 and then 2 here, right? So 3 roots. So it's going to be, first fraction is going to be a over x plus b over x plus 2. And since x plus 2 has degree 2, the third factor is going to be x plus 2. Sorry, not 3. C. The third one is going to be x plus 2 squared. This is how you work. Okay? You see my roots, I pick them out, and I go on. Now, what do we know? This numerator here is going to be the same as this here. So, a times x plus 2 squared, right? We want to make the common denominator. Plus b times x plus 2, right? I'm multiplying by everything else. Plus c times x. This is x plus 2 squared. What's the common denominator here? The common denominator here is x plus 2 squared. Look at the denominator here. X, what does it need to become like this? It needs x plus 2 squared. That's why I multiplied the a by x plus 2 squared. Then b, what does it need to be like this? It needs an x and it needs an x plus 2. So I multiplied x and x plus 2, right? To become like this. And then C, what does it need? It just needs an X. Now we know this is all equal to our original numerator. So fast. Yalla. So we split. We form the equation. What's the third step? Your roots now. What's the root of this? Negative 2, right? So let's substitute negative 2. A into negative 2 plus 2 squared plus B into negative 2 times negative 2 plus 2 plus C times negative 2 equals 10 times negative 2 plus 8. This can all be done in your calculator by the equation mode. Huh? So A into negative 2 plus 2, this is 0. Negative 2 plus 2, 0. So I'm left with negative 2C equals negative 2 times 10, which is negative 20, plus 8 is negative 12. So you get C is equal to 6. So I can easily know that my C now value is what? 6. So I can put here what? 6, as you can see here. Now, let's try a different root. Over here, we found the root of this one. The root of this one is also the same thing. What's the root of this? The root of this is 0. If you like x as 0, because there's nothing. It's not x plus 1, it's not x plus 2. It's just 0, right? It's just x. So how do you make x 0? When x is 0 itself, right? So let's substitute now 0. A into 0 plus 2 squared plus b into 0 times 0 plus 2 plus c times 0 equals 10 times 0 plus 8. This is 0. It gets cancelled because 0 times b. This gets cancelled. So what am I left with? A times 0 plus 2 squared is 4a equals 10 times 0 is 0 equals 8. So a is equal to 2. Okay, so now we have our a value. We can put it over x, right? So 2 over x. Okay, now we're left with b. But someone's going to come and ask me, Walid, how do I know how to find b? If the only roots here are 0 and 2, and we substituted them, and we only got our a value, and we only got our c value. How do I find now b? Here is the trick. You need to think outside the box. We know now what a is, and we know now what c is. So let's substitute our a value and c value in. Okay, we're going to do a, which is 2. So 2 into x plus 2 squared plus b into x plus 2 plus c, which is 6, so 6x equals 10x plus 8. So now what do you do here? What do you do in this case? You have b and x. What do you do? Very easy. Choose any x value. In this case, when you found a and c and you're missing one more letter, you choose any x value. Okay, you substitute your letters back in and now choose any x value you want. Let's take, I don't know, 1. So 2 into 1 plus 2 squared plus b into 1 plus 2 plus 6 times 1 equals 10 times 1 plus 8. Let's fix it. So 2 times 1 plus 2 squared is 3 squared times 2. So 9 times 2, 18. Plus b times 3 is 3b plus 6 equals 18. So this 18 and 18 cancelled. You get b is equal to negative 2. 3b plus 6 equals 0. So b equals negative 2. So as you can see here, we found our a, we found our b, we found our c. Okay, so over here, let's plug all our letters back in. So a we said is 2. So 2 over x. B we said is negative 2. So minus 2 over x plus 2. And then c we said is 6. So plus 6 over x plus 2 squared. There you go. Is it long? Yes. Is it hard? I don't think so. It's just long. Okay, so this is what you get. 2, 2, 6. They already put the negative here. That's why you don't put negative 2. Okay. Question 3. Okay, I'm gonna do all the splitting stuff. Okay. Same thing. Okay, you don't need long division here. Okay, now here it says using long division, but long division is a different trick that you don't really need, especially not for this level. You'll do it when you do calculus next year, or hatta in university you'll do it. But that's not the point now. So over here, same thing, we have another polynomial. So we have, as you can see here, 1, 2, 3 factors. So let's start splitting. See, this is the trick here. This is why you need to do long division. Okay, yeah. After looking at it, you do need to do long division. I just want to see if there's anything else here that you need long division for. No, mafi. Okay, so here's the trick. The rule actually is, this is partial fraction. I taught you here partial fraction decomposition. It's PFD. Okay, this is to kind of simplify a fraction. Okay, what if you had polynomial over polynomial, right? And this is how every fraction is. So I have a polynomial over polynomial. What's a polynomial? Any equation, x squared plus 5. I don't care. Okay, polynomial over polynomial. Now, you do partial fractions if the degree of p is less than the degree of g. Okay, but if you have something like 3x cubed plus 5x squared over 2x cubed plus 4x squared. If you have something like this, where the degrees are the same, you can't proceed with partial fraction decomposition until you do an extra step, and that's called long division. Because when you do long division now, you're going to get a number plus a remainder. That remainder is a fraction, and then after you get that fraction, you can do partial fraction decomposition on that fraction. Okay, so let's do long division. Okay, this teaches you here. You have to do that here. You're going to be, what do you mean? They don't have the same degree. So here you have cube, yeah? And here, what's the degree? You have 1, 2, 3 x's. So when you expand this, you're going to get something x cubed. It's actually going to be 1x cubed. But that's not the point. You're going to get something x cubed, okay? So since you have the same degree, you need to do long division and then partial fraction, okay? So let's do long division over here. Before we do long division, we have to expand this. X minus 1 becomes x squared minus x. And then putting that into x plus 2, you get x cubed plus 2x squared minus x squared minus 2x. Okay, which is the same as x cubed plus x squared minus 2x. So this is your denominator. So let's rewrite this over here. This is the same as 3x cubed minus 17x plus 2 over x cubed plus x squared minus 2x. You want, now, what do we do? Since it's the same degree, you have to do long division. Okay, yeah, let's do long division. X cubed plus x squared minus 2x. And 3x cubed minus 17x plus 2. Yeah, you divide, multiply, subtract, right? DMS. This is what I taught you guys on my channel before. So to go from x cubed to 3x cubed, you have to multiply by 3. So since you have to multiply by 3, x cubed times 3 is 3x cubed. X squared times 3 is 3x squared. Minus 2x times 3 is minus 6x. Yeah, subtract. This gets you 0. Minus 17 minus 3 is minus 20. Then 2. Okay, then you have nothing with the 6x, so it becomes plus 6x. And then 2 minus 0 is just 2. Okay, perfect. Or you can do 2 minus 6x, which is 2 plus 6x, which is the same thing. Okay, so you get minus 2. Oh, I didn't write the x squared here, sorry. You get this. So this is now the remainder, because you have here the power is 3 and the power here is 2. When it's not the same power, you can't continue the long division. So you get that the answer is 3 plus your remainder, which is negative 20, x squared plus 6x plus 2. But since it's your remainder, you have to put it over your original fraction, okay? 3x cubed minus 17x. Sorry, no, not the original fraction. Over this here. X cubed plus x squared minus 2x. So this is after you get long division. Again, if you don't know what I just did, I did long division and I ended up with a remainder. You can't continue dividing if the power here is less than the power here. You can't. There's no way. What are you going to multiply x by to get something with x squared? Right? You can't. So this is your remainder. So it's 3. The answer of this division is 3 plus your remainder. When in math, when we have a remainder, that means we're dividing. It's something over this. That's what the remainder means. Okay? So you now have your fraction that you can now do partial fraction decomposition because the degree of the numerator is less than the degree of the denominator. So let's do partial fraction decomposition of this. Minus 20x squared plus 6x plus 2 over x cubed plus x squared minus 2x. Can we do partial fraction decomposition if the denominator is not factored? No, we can't. Do we know what the denominator is factored? Now, if you're looking at it for the first time, obviously it's a bit hard to factor, but I mean, we got it from here. This is what our denominator is, right? So x minus 1, x plus 2. Yeah, let's do partial fraction decomposition. We're going to split it into a over x plus b over x minus 1 plus c over x plus 2. Now, let's form our equation. Ax minus 1, x plus 2. Remember, you multiply the letter by everything else that you need. Plus b x plus 2 plus c x minus 1 equals our original numerator minus 20 x squared plus 6x plus 2. Yalla, what's the third step? You now substitute your roots. Let's start with the first root. What's the root of x minus 1? 1. So let's substitute 1. You're going to get a 1 minus 1, 1 plus 2, plus b into 1, 1 plus 2, plus c into 1, 1 minus 1, equals minus 20 into 1 squared plus 6 times 1 plus 2. Type, we know this becomes 0. And this over here becomes 0, because 1 minus 1, 1 minus 1. So you're left with b times t, so 3b is equal to minus 20 plus 6, which is minus 14 plus 2, which is minus 12. So you get b is equal to negative 4. Now you got your b. Let's continue. What's our next root? Let's try now negative 2. The root of x plus 2 is negative 2. So let's try now negative 2. Substituting negative 2, let me put this in a box. Substituting negative 2, you're going to get a into negative 2 minus 1, negative 2 plus 2, plus b into negative 2, negative 2 plus 2, plus c into negative 2, negative 2 minus 1 equals minus 20 negative 2 squared plus 6 times negative 2 plus 2. So this becomes 0 because it's negative 2 plus 2. This becomes also 0. So you're left with here minus 2 times minus 2 minus 1 minus 3, minus 3 times minus 2, 6. So 6c equals Heidi 4 times minus 20 is minus 80. Minus 80 minus 12 minus 92 plus 2 minus 90. So c is negative 15. So I got c as negative 15, and I'm taking a look. It's 2 here. Now I had to go into ChatGPT to have to feed my solution to see, you know, like, where did I go wrong, bro? Because I'm so lost. And then I'm reading, and I don't know, maybe someone said this, you know, while watching, but I had minus 17x, and I added that with minus 3x squared, and I got minus 20x squared, which is completely wrong, because you can you can't add x with x squared. So let me fix this here. The remainder now becomes minus 3x squared minus 17 minus minus 6 is minus 11x, then 2 minus 0 is plus 2. So this is the new remainder, and I don't know, somehow I still got the same answer for b, which is, oh no, I didn't. What did I? Yeah, I got the same answer for b. The numerator for x minus 1 is negative 4. I got that. But المهم, this is the new remainder, so let's just fix this here. Let's fix this to minus 3x squared minus 11x plus 2. So let's fix this here. Equals the, so minus 3x squared minus 11x plus 2, and over here, I'm just gonna fix this over to minus 3. What did I substitute? I substituted 1 here, so minus 3 times 1 squared minus 11 times 1 plus 2, which gets you, does this get you 12? Minus 3 minus 11, yeah, it gets you 12, so that's a coincidence. But anyways, moving on, over here, and I have to fix this into, let's fix this here. Substituting negative 2 into our numerator gets you negative 3 times negative 2 squared minus 11 times negative 2 plus 2, which is negative 12 plus 22 is 10 plus 2 is 14. So I'm gonna get how much? No, how much? I did the calculations wrong. Akid. 12 negative 12 plus 22 plus 2 is 12. Okay, so I get 6c is equal to 12. So c is equal to 2. And as you can see here, that's correct. Over x plus 2, 2 over x plus 2. Okay, so now we have c, we have b. Is there any other root we can substitute? Taking a look at our equation here. We substituted the first root, which is 1, and the second root, which is negative 2. What's left is x as 0. So I need to substitute now my third root, which is 0. I'm going to do that over here. Okay, substituting 0. We're going to get a into 0 minus 1, 0 plus 2, plus b into 0, 0 plus 2, plus c into 0, 0 minus 1, equals minus 3, 0 squared minus 11 times 0 plus 2. So let's see what can we cancel. This b times 0 cancels, this c times 0 cancels, this 3 times 0 cancels, with this 11 times 0 cancels. So what am I left with? A times 0 minus 1, which is negative 1a. So negative 1 times 2 is negative 2a. Do this here. Equals, as you can see here, 2. So you get a is negative 1. So we finished our partial fraction decomposition. So اتفقنا that we have this 3 here. We have 3 plus the remainder, which is this. And we decompose this fraction into a over x plus b over x plus 1 plus c over x plus 2. So this is the same as 3 plus the decomposition of this, which is a, which is negative 1 over x, then b over x minus 1, which is negative 4, so negative minus 4 over x minus 1, and then c over x plus 2, we found c as 2, so plus 2 over x plus 2. So let's compare this with the answer. Is this correct? As you can see here, yes, it is. There you go. How do you know مثلا to put 1 or 2? Because they put the minus into, which one's minus? The 1. So you put the 1 here. And then the plus is the 2. Okay, very easy. Just very long. That's the problem. Okay, question 4. This is integration. I'm gonna skip integration. I want to do partial fraction decomposition first without the integration. And then we're gonna do... Okay, we can do this one here. Okay, so for question 9, I really don't like the way that they wrote the layout. It's very ugly in my opinion. Okay, so we're gonna split it as we normally do and ignore the letters they put because I'm gonna use different letters myself. Okay, so we have 2t4 minus 4t cubed minus 3t minus 1 over t squared plus 1. I'm gonna expand this denominator first to show you that this degree of the numerator is the same as the degree of the denominator. And I told you before that if you have this, what do you need to do? You need to do long division and get a remainder. Okay, so the first thing you do is check your degrees. You have 4 here, you have 4 here. You can't split. You're not allowed to split. Okay, type. So to split, before we split, we need to do long division. Type, yeah, let's do long division. T4 plus T2 into 2t4 minus 4t cubed minus 3t minus 1. Yalla. T4 into T4 into 2t4, you multiply by 2, صح? So since you need to multiply by 2, t4 times t2 is 2t4, t squared times 2 is 2t squared. Yalla, subtract it. 2t4 minus 2t4 is 0. Here we minus 4t cube. There's no cube term to subtract it with, so we just do minus 4t cube. I know there's a 0 here, right? There's no power 3 term. So minus 4t cube minus 0 is minus 4t cube. Okay, and then there's nothing to add to the 2t squared here. So 0 minus 2t squared is minus 2t squared. Minus 3t, there's nothing here, so minus 3t minus 1. Okay, so you get this. Now, what do you multiply t4 by to get to 4t cube? Nothing, right? So that means, خلاص, you can't divide anymore, because the power here is 4, the power here is 3. If they're not the same power, you can't do it, okay? Sorry, if the power here is less, you can't continue dividing. So this is your remainder. So after doing the division, you can get that this is equal to 2 plus the remainder minus 4t cubed minus 2t squared minus 3t minus 1 over t to the power 4 plus t squared. As you can see now, we did our splitting. Remember, the remainder always goes over the divisor, okay? The remainder always goes over the divisor. Okay, as you can see here, we split it into a fraction now that has a power where the numerator is less than the degree of the denominator. So, can we split now? Of course we can. Yeah, let's split. So, what I'm going to do is I'm going to factor out the denominator, because we know we can't split if we don't have a factor denominator. So, this is the same as 2 plus a over, what's the first factor? T, right? Because t squared, remember, is t times t. Plus b over t squared, right? Plus, here is the tricky part. Someone's going to tell me c over t squared plus 1. Now, this is where you're wrong, and this is a new concept, and this is why I wanted to solve this question. Okay? If your factor is a quadratic that can't be factored, مثلا x squared plus a, a is not a squared term. If this is one of your factors at the bottom, then the numerator can't just be a constant c مثلا. No. It has to be a x plus b. So it has to be two terms together. You get what I mean? So it's not allowed to just be a over x plus x squared plus a. No. It has to be a linear term. Linear, yani you need to have x. So you're not allowed to do this. No. It has to be ax plus b over x squared plus a. When is the only time that you do this? If your factor is a quadratic that is not able to be factored. It's not possible to factor t squared plus 1, right? So that's why we keep it as t squared plus 1. That's the factor. So since it's a quadratic, what do I have to write here? Ct plus d. I would write cx plus d, but why didn't I do that? Because here we're working with t, we're not working with x. So ct plus d. So this is very nice. You did your splitting. After this, everything gets very easy, right? Type. Let's ignore the 2. We're working now with these, right? So what do we do now? We form our equation. So a times the common denominator is t squared plus 1. We already have a t, so we're missing one more t, and we're missing t squared plus 1. So t times t squared plus 1. b has t squared. So how do we go from t squared to t squared plus 1? We already have that t squared. We're missing the t squared plus 1. So b into t squared plus 1. Plus, now ct plus d, we're going to multiply that by what are we missing? We have t squared plus 1 here. What are we missing? We're missing the t squared. We know that when you multiply these, you should get the original numerator, which was what? Minus 4t cubed minus 2t squared minus 3t minus 1. So you got your original numerator. Now, what did I tell you you do? Try your zeros. Type, let's try our zeros. T squared plus 1 has no zeros because it's always positive. Obviously, the only zero we have now is when t is equal to 0. Okay, so when t is equal to 0, you're going to have a into 0 plus 1 plus b into 0 plus 1 plus ct plus d into 0 equals minus 4 into 0 minus 2 into 0 minus 3 into 0 minus 1. So you're going to get that this is 0, this is 0, 0, 0, 0. So you're going to get b is equal to negative 1. Type. Now, someone's going to come and ask me, Walid, we have 3 unknowns left, A, C, and D. How are we going to solve them if we have no more zeros that we can try? Look, we have no more zeros that we can try. So this is where a new concept comes. And I told you, you can use, you just try out any value of t and solve. But since you have 3 unknowns, that's going to take you ages and ages and ages. It's going to take you way too long. So I'm going to teach you a new concept called comparing coefficients. Okay, so let's take a look at the coefficient of t cubed. I'm gonna show you something. Okay, if I give you an equation, مثلا 4t squared plus 5t plus 3 is equal to x plus a t squared plus 7 plus b t plus 5 plus c. Okay, I'm gonna tell you find let's put this as 1, actually 1, not x. I'm gonna tell you find a, b, and c. How would you do it? طب, as you can see here, we have square terms, t squared, t squared. So since they have the same term and we know that they're equal to each other, we can just compare their coefficients. So 4 should be equal to 1 plus a, and therefore a is equal to 3. Now over here, we have coefficients of t, 5 and 7 plus b. So 5 is equal to 7 plus b. So therefore b is negative 2. And we know that this constant term here should be equal to this here. So 3 is equal to 5 plus c. So again, c should be negative 2. So as you can see here, you had 3 unknowns, and you figure them out so easily by doing something that we call comparing coefficients. Okay, your teacher may have told you a different way to solve this, but this is what I've seen during solving. This is the easiest way I've seen. So let's try our method called comparing coefficients, right? Comparing coefficients. Let's do it. So let's start with our first coefficient, and that's the coefficient of t cubed. So let's see, minus 4 is equal to what? Minus 4 is the coefficient of t cubed. You want to see here, what is the coefficient of t cubed here? Take a look. T squared plus 1. Can I get the t cubed here? Yes, I can. When I expand this, I'm going to get that the coefficient of t cubed here is a, right? It's a t cubed, right? So a. That's the first coefficient of t cube. Here, b times t squared plus 1. Is there any way that I'm going to get t cube here? No. Okay. ct plus d times t squared. Type, let's see. Is there any way I'm going to get a t cube here? D times t squared will just give me dt squared, and I don't want that. Ct times t squared will give me ct cube. So I am getting a t cube term. So plus c. So as you can see here, we got our first equation. Minus 4 is equal to a plus c. Let's continue. So this is for t cube. Now let's try for t squared. Okay, here, is there any way I'm going to get t squared? When you expand this, I'm going to get t cube, and I'm going to get t, because there's no t squared term after expanding. Here, is there any way I'm going to get t squared? Yes, b times t squared is going to give me bt squared. So after expanding, I'm going to get bt squared. Okay, so for t squared, we found our first one is b over here. Here, ct plus d times t squared. Ct times t squared, we said ct cube. But d times t squared is dt squared. So I'm going to get a term with t squared. So the coefficient is d. How much is the coefficient of t squared in the actual equation? Minus 2. So as you can see here, we found our second equation. Now, we said that b is negative 1 from trying the 0 here. So immediately you don't have to do this now. You can do it all the way at the end. But you know what, I'll do it all the way at the end so I don't confuse you. Okay, now let's try the coefficient of t. Coefficient of t. Let's see here. The coefficient of t in the actual equation is negative 3. Let's see here, what's the coefficient of t? Here, are we going to get any t? A times t times t squared is at cubed. A times t times 1 is at. So we have an a over here. Okay, and then b times t squared is bt squared, and b times 1 is b, so there's no t here. Ct times t squared is ct cubed, and then d times t squared is dt squared, so there's no t here. So the only t I'm going to get is at. So minus 3 is equal to a. طب أيوة. You now found 3 equations. Now you can continue and keep on doing it for the constant term, but it won't work here. Okay, so this is all I need. Really, this is all I need. I know that minus 3 is equal to a. So if I know minus 3 is equal to a, I can substitute that minus 3 up here. So minus 4 is equal to minus 3 plus c, because a is minus 3, right? We said minus 3 is equal to a. So that means c is equal to negative 1. So I know minus 3 is equal to a. I know c is equal to negative 1. Tab, over here we're stuck. We don't know b or d, but we know that we found b over here. So minus 2 is equal to negative 1 plus d. So d is also equal to negative 1. So we found a, c, d, and we already found b. So this is one of the harder ones. So صراحة they don't usually come like this. So let's break it down. أول شيء, if degree of numerator equals degree of denominator long division. Second step is split. If a factor is a quadratic, then the numerator has to be linear. Linear means, you know what a linear means? Means y is equal to mx plus b. This mx plus b, that's what linear means. Like something times x plus another something. Okay? That's what we say with linear. That's what we mean with linear. 3, form your equation. Then to solve your equation, first thing, try the zeros. Second thing, compare coefficients. Whatever you want, by the way, it really works. Okay, so this is my way of solving. It works with me. So over here, we found our a, b, c, d values. Let's plug them into our fractions that we split. So 2 plus a, we said a is negative 3, so we're going to make it minus 3 over t. Plus b over t squared, we said b is negative 1, so minus 1 over t squared. Plus ct plus d. C we said is negative 1, so plus negative 1 t plus d, which is negative 1, over t squared plus 1. So this is our answer over here. So obviously, the constant term is going to be 2. So in this case, we're going to change our a with 2. The numerator for the t is what? Negative 3. So we're going to put the b as negative 3. The numerator for t squared, see how they did it here is weird. This is why I don't like it. This is why I ignore what they do, and then I just do it myself, and then I fill in whatever they're asking me for. Okay, over here, the numerator for t squared. What's my numerator for t squared? It's -1. So you're gonna come tell me, what they said ct plus d. So obviously, since there's no t term in my numerator for t squared, this c has to be 0. Okay, according to what they said, which is completely disgusting. I hate why they put it like this. It should just be c. I don't know why they put ct plus d. Okay, so according to what they said, up here the ct plus d should be -1. This is what I did, right? To do that, I can't have that. Okay, so to do that, basically c has to be 0 and d has to be what? -1. And they filled out the rest for us, the minus t minus 1. Sorry, they factored out the minus and they made it t plus 1 over t squared plus 1. They did it for us. It's not easy, it's not hard, it's just very long. Okay, and it's new for you guys, so I see why you're confused. Okay, here for question 10 again, and I told you I'm skipping all the integration questions, and then I'm gonna come back to them at the end. Okay, المهم, select the two partial fractions, which is equal to this. Okay, you want to split this. First thing you check is the degree. Degree up is 2, degree down is 3. Since it's not the same, عادي, you can split without having to do long division. So we're gonna split this up into 2. What are my factors? T and t squared plus 2t plus 6. So a over t plus, since my other factor is t squared plus 2t plus 6, is this a quadratic? Yes. So does that mean I put b here? No, we're not allowed to put b. I have to put bt plus c, right? I need to make it a linear term since it's a quadratic. Okay. If it's just if it's a linear term down, I can put b, but since it's squared, I need to put bt plus c. You need to be 1 degree less than the denominator, than the factor. Okay. طيب, over here, what's it called? Yeah, some people might say, okay, how do you know this is the factor? Try factoring it. Sometimes she puts something that can be factored. So some people directly they don't try, but you need to try factoring t squared plus 2t plus 6. You have your calculator. As you can see here, I get an imaginary number, so it's not factorable. So just continue. So I'm gonna split it into these two. We did our, forming the fractions. Now it's very easy to do it. How do we do it? We form our equation now, right? So what do we need to make our common denominator? What do I have to multiply a by? I already have the t. What do I need? I need the t squared plus 2t plus 6, right? So t squared plus 2t plus 6. Okay, now b, the bt plus c, what do I need to make it t squared plus this here? I need a t, right? Now this should all be equal to the original numerator, t squared plus 1. Okay, so do I have any zeros here? The first thing I tell you to solve is always try your zeros. Over here I don't have any zeros, except for one thing, and that's t equals 0. Because this is always positive, so there's no zeros for it. So I'm going to try t equals 0. If I try t equals 0, I'm going to have a into 0 plus 2, 0 plus 0 plus 6 plus b into 0 plus c times 0 equals 0 plus 1. Okay, so as you can see here, this doesn't cancel. You're going to get 6a. And over here, you're going to get this cancels because it's all multiplied by 0. 6a equals 1, so a is equal to 1 over 6. So very easy, we found this. Now, is there any other zeros you have here? No. So what do you have to do? You can try other values and keep on solving, it's fine. But I told you I like to do comparing coefficients. So let's compare our coefficients. What do we have here? We have t squared plus 1. So let's first compare the t squared term. Okay, for t squared. What is the coefficient of t squared originally? In the original equation, it's 1, right? It's 1 t squared. So 1 is equal to, over here, what's my coefficient of t squared? A times t squared gets me a. So like over here, when you expand this, you can get a t squared plus 2at plus 6a. And over here, you're going to get bt squared plus ct. Now, in the previous question, I didn't expand it like I did now because it was a lot of terms. So I just did it quickly. You can easily see, am I going to get it? Ask yourself, am I going to get a t squared term when I multiply this by this? And obviously, without expanding, I can see, how will I get a t squared term over here? I'm going to get a t squared term when I multiply a by t squared. So when I multiply a by 2t, مثلا, obviously you're not going to get a t squared term. Where's the second t going to come to make the 2t a t squared? Okay, so basically, So the coefficients of t squared here are going to be a, and over here, without expanding, ask yourself, will I get t squared at all? bt times t squared by bt times t will get me bt squared, as you can see here. C times t is ct. So my coefficients of t squared are a and b. So 1 is equal to a plus b. Type. And I don't know, let's just keep this as equation 1 and then substitute it at the end. Okay, what else do we have? We have coefficient of t squared and we have a constant term. When will I ever get a constant term? As you can see here, I expanded it fully. Constant term means I don't have t. In what term here do I not have t at all? The only time I don't have t at all is here, 6a. Doing the constant term, you're only going to get that 1, doing the constant term, you're going to get that the constant here is 1, and over here, the only constants you have is, the only term that doesn't have t, constant, is 6a. Okay, so you're going to get that 1 is equal to 6a over here. So 1 is equal to 6a, and you're going to get a is equal to 1 over 6, which is also what we got over here. Okay, so we know that a is equal to 1 over 6, so can we find b? Yes, we can. That means b is equal to 1 minus 1 over 6, which is 5 over 6. Okay, when you do substitute a as 1 over 6, you can get 1 minus 1 over 6, so b is 5 over 6. You now know a is 1 over 6, and b is 5 over 6. Now we're missing c. We did our comparing coefficients. We tried our zeros. What do we do? How do we find c? So, in this case, when you have nothing left and you tried everything, you're left with only one solution, and that's called trial and error. To do trial and error, it's very simple. I think everybody knows how to do trial and error. So a, we know, is 1 over 6. So we're going to write 1 over 6 t squared plus 2t plus 6. Plus b, we know, is 5 over 6. So 5 over 6t plus c into t equals t squared plus 1. So trial and error is what I originally taught you. When you have 3 variables and you need the 4th, you just need to substitute any value of t that you want. The easiest value of t is always 1, because it's just there. Usually it's 0, but we already tried 0, and we know what we got. So 1 over 6 into 1 plus 2 plus 6 plus 5 over 6 plus c times 1 equals 1 plus 1. If I fix this, you're going to get 3 plus 6, 9 over 6. 9 over 6 plus 5 over 6 plus c equals 2. You're going to get 14 over 6 plus c equals 2. That means c is equal to negative 1 over 3. Yeah, you get c is negative 1 over 3. So you now have a, b, and c. Let's make our equation. Let's substitute them back into the partial fraction. So we know a is 1 over 6. So 1 over 6 over t plus b, we know, is what? 5 over 6. 5 over 6 t plus c, which is negative 1 over 3. All this over t squared plus 2t plus 6. Now, how do you do this? First thing here, 1 over 6 over t. I think I've said this on my channel before, is when you have a denominator up and you have a denominator down, you can just throw your denominators together. Okay, so 1 over 6t. Type. Over here, how do you do this? The first thing you're going to do is, I don't like having 3 fractions. Okay, I like having 1 fraction up, 1 fraction down, if I'm ever going to solve something like this. So the first thing I'm going to do is, I want to make this one up here as 1 fraction. If I make it as 1 fraction, it's going to become multiply by 2, multiply by 2. You're going to get 5t minus 2 over 6 over t squared plus 2t plus 6. Okay, just multiply by 2 up and down. Becomes minus 2, so 5t minus 2 over 6, and then whatever. Yeah, type. Now, what did I tell you? You need to, if you have denominator over denominator, just throw the denominator up with the denominator down. Okay, and it's going to become 5t minus 2 over 6 into t squared plus 2t plus 6. Okay, there you go. So what are your factors? 1 over 6t and 5t minus 2 over 6t squared plus 2t plus 6. Okay, for number 11, same thing. خلاص, at this point, I think if you're this far into the recording and you've been watching the whole time, I think else you've gotten used to splitting into partial fraction. So I think you should try and attempt this yourself if you've been watching the whole way. If not, here is the explanation. So first thing we check is what? The degree. So degree up is 1, Degree down is 3 because you have t times t squared is t cubed. Okay, very easy. Please, the first thing you do is check if this quadratic here can be factored, because sometimes she might trick you and put one that can be factored. So let's check t squared minus 3, t squared, خلاص, t squared minus 3t and then 2. And yes, as you can see, it can be factored. So I have the two roots, which are 2 and 1. So that means t squared minus 3t plus 2 can be rewritten as t minus 2, t minus 1. If you already know how to factor it without using calculator, that's amazing. Do it by yourself. So this is actually 2t minus 1 up, and you have t, then t minus 2, t minus 1. So as you can see here, the denominator was still factorable. So we finished our first step, which is check the degree. We finished our second step, which is fully factor out the denominator. What's the third step? Split it into factors, right? So a over t plus b over t minus 2 plus c over t minus 1. Now this is going to be a very easy one. Is equal to this, okay? This is going to be very easy. Why is it very easy? Because all of these have zeros. T has a 0 as 0, t minus 2 0 is 2, and t minus 1 0 is 1. So the zeros are going to be very easy. So this is going to be one of the easier ones to do. So let's start. As you can see also, none of my factors are quadratics. You see here t minus 2, t minus 2, none of them are quadratics. So that means I only have constants as my numerators. As opposed to the past two questions that we solved, we had linear expressions as my numerators. So this is a very easy one. Inshallah, they're all like this in the exam. We know that the numerator here should be equal to the numerator here. So let's form our equation. What do we need here? A, we have t. What do we need in the denominator? We still need a t minus 2, we need a t minus 1. So a times t minus 2 times t minus 1. Plus b. What do we need? We already have the t minus 2. We need a t and a t minus 1. So b into t minus 1. C, we have the t minus 1. We need the t and t minus 2. صح? So c into t minus 2 equals the original numerator, which is 2t minus 1. So let's try our zeros. The first zero I'm going to try is this one, because it's the first one I see in front of me, which is 2. So the first zero is substitute t as 2. Let's start. T as 2, you're going to get a into 0 times negative 1 plus b into 2 times 1 plus c into 2 times 0 equals 2 times 2 minus 1. So you get a is equal to, this cancels, solving this cancels, this gives you 2b, this cancels, so 2b equals 3, so therefore b is equal to 3 over 2. Very nice. Let's continue. What's our second zero? Remember, the first step to solving is always check your zeros. Sometimes we don't have zeros, so we have to compare coefficients. But here we have so many zeros, so it's very easy. The next zero I can see is 1, using t as 1. So substituting t as 1 would give me a into negative 1, 0, plus b into 1, 0, plus c into 1, 1 minus 2, equals 2 times 1 minus 1. And why am I doing it like this? You can write 1 minus 2 and then 1 minus 1. So I'm just saving time and solving it before I write it down. It saves you space and time, okay? So this a times 0 cancels. This b times 0 cancels. You're going to get c, negative c, equals 1. So you get c is equal to negative 1. Perfect. Do we have any other zeros? Some people might say no, but don't forget, how do you make the expression t0? You can just substitute t as 0. Okay, so you're going to get a into negative 2, negative 1, plus b into 0, negative 1, plus c into 0, negative 2, equals 2 times 0, minus 1. So this cancels, you're going to get, this cancels, and you're going to get 2a equals negative 1. So therefore a is equal to negative 1 over 2. Yalla, you're done. You found a, b, and c. So let's substitute them back into our partial fraction. A, we said, is negative 1 over 2. So it becomes negative 1 over 2 over t, plus b, which is 3 over 2. So 3 over 2 over t minus 2, plus c, which is negative 1 over t minus 1. So remember, like I told you, denominator over denominator, you throw them down together. So negative 1 over 2t, plus, again here, denominator, throw it down. So 3 over 2t minus 2. Please don't forget to put it in brackets. Then over here there's no denominator, so we just keep it as minus 1 over t minus 1. So this is our partial fraction. So what are the three partial fractions? 3 over 2t minus 2, minus 1 over t minus 1, and minus 1 over 2t. Very simple. Question 12. I think the rest of this is all partial fractions, so I'm just going to finish to the rest of the quiz, then go back and do the integration questions, okay? What is the value of b in 29? Okay, so, okay, very easy. So easy, wallah. They gave you, wow, okay. This is a very easy one to split. As you can see, they want us to split it. So we already have a fully factored denominator. The degree up is less than the degree down, so everything is done. All we need to do is just split. So we get a over the first factor x plus b over the second factor x minus 2. Like I told you, I don't like looking at this here until I'm done solving. Okay, I really don't like. So let's do this. We split it already. What's the second step is to form our equation, right? So a times, what are we missing in our denominator here? We need x minus 2, so we're going to multiply by x minus 2 plus b. What are we missing? We have x minus 2, we need an x, right? Equals, all of this equals the original denominator. Now what are my zeros? We're going to start first x equals 2. So as you can see here, there's no quadratic, there's no root that's a quadratic, so you need to write a linear. You already have your zeros all there. It's very, very easy. You only have two factors, so it makes it so fast. So this is the type of question you're definitely going to see in your exam. Okay, a times 0 plus b times 2 equals 29 times 2 minus 24. هيدي بتروح. You're going to get 2b equals 58 minus 24, which is 34. So you get b is equal to 17. So as you can see here, we're already done. They already want b. So there you go. B is 17. Okay. خلاص, easy. You don't need to continue solving. If they asked for a, what would you do? You substitute x as 0, because that's the second 0 over here, right? The second 0 would be substituting x as 0. So a into negative 2 plus b times 0 equals negative 24. This goes, you're going to get negative 2a equals negative 24. So a is equal to 12 if they asked for it, okay? Question 13. What's the value of a? Same thing, same type of question. Let's do it, yalla. First thing you check is the degree. Degree up is less than degree down, so it's very easy. Up it's 1, here it's down, because x times x is x squared. So degree is easy, done. Is my denominator fully factored? Yes, it is. So let's start splitting, right? So this comes out as a over x minus 3 plus b over x. Do we need to have any linear term? No. Why? Because all my factors, none of them are quadratics. Type. We know now we need to form our equation. What does this one need here to have this denominator? It needs an x. So a times x. What does this one need here to have this denominator? X minus 3. So plus b times x minus 3. This equals the old original denominator. Type. Do we have any zeros? Of course we do. We have a 0 here and a 0 here. Let's start with our first 0. To save you time in the exam, since they want the value of a, okay, and you can see the value of a here is the same as our a here, okay? Since they want the value of a, choose the one that makes b 0, okay? So it saves you time in the exam. I'm telling you, so you save time. Because if you choose x as 0, that means you're going to make a 0, and you're going to end up finding b before you find a. So to save the extra 30 seconds, choose the 0 as b is 0, the one you don't want to find first, okay? So we're going to choose x equals 3 first. So you're going to get a times 3 plus b into 3 minus 3 equals 32 times 3 minus 15. So this gets you, this cancels. You're going to get 3a is equal to 32 times 3 is 96 minus 15 is 81. So you get a is equal to 27. Okay, perfect. Very easy. So as you can see here, since I chose b 0, I cancelled out b and I found a first. If you ended up choosing 0 as x first before choosing x as 3, you're gonna, it's nice, yani عادي, you're gonna find b before you find a, which is gonna waste you some time. Okay, so very easy. 14. What's the value of b? Okay, same thing here. Okay, for 14, now it might look a bit scary, but let's take a look. Actually, the degree here is 2, the degree here is 3, so it's smaller, so we don't need to do long division. Second thing is my denominator fully factored? Yes, it is. Okay, some people in grade 11, now we're moving into 12, we can call you 12S, they don't know that x squared plus 4 cannot be factored. It can't be factored. You just can't. Okay, so people put it as x plus 2 squared. Please don't do this. Okay, it's not. يعني والله you're just عم تخبص والله. Okay, x squared plus 4 is not x plus 2 squared because x plus 2 squared is x squared plus 4x plus 4. So you're missing that 4x. It's not there. Okay, so anyways, our denominator is fully factored, so we can immediately start by splitting. So let's start. It's going to be a over x plus something over x squared plus 4. Now I was going to write b, but we guys at this stage of the video, we need to understand that since our second factor is, as you can see, it's a quadratic, right? It's a quadratic. So would it be correct to only write b? No, I have to write bx plus c. Okay, you need to make it a linear. All right, so let's form our equation. What do we need for a here? We have the x, we need x squared plus 4, right? So we're going to multiply a by x squared plus 4. The bx plus c, we have the x squared plus 4, we just need an x. So bx plus c, we're going to multiply it by x, and this should all be equal to my original numerator. Okay, perfect. What are my zeros? Like I told you, the first thing you try is always see if you have zeros. Let's see. X squared plus 4 can never be 0. It's not factorable. But we know x can be equal to 0. So if you do x equals 0, a will be equal to, a into 4 plus b times 0 plus c into 0 equals 18 times 0 plus 0 minus 12. So let's cancel. This will be 0. This will be 0. This is just 0. So you're going to get 4a equals negative 12. So therefore a is equal to negative 3. صح? Very easy. طيب, since a is equal to negative 3, do we have any more zeros where we can continue? Looking here, the only zero we had was x equals 0. No more zeros. What do we do in this case when there's no more zeros? We tried all our zeros and we still have letters that we haven't found. We need to do comparing coefficients, right? Comparing our coefficients. So let's take a look over here. We're going to start first with the x squared coefficient. Comparing the x squared coefficient, we have 18 on the right. On the left, what do we have for x squared? Now, if it's easier for you, and it's a bit hard, if it's a bit hard for you to tell what's the coefficient of what term without fully expanding, then I suggest that you expand it. It's an extra step. Wallah, it's just a small extra step. Okay? It makes your life way easier and it makes things more clear. Okay? So what's the coefficient of x squared here? You can see that the coefficients of x squared are a and b. So a plus b. Now, what's the coefficient of x? We're going to call this equation 1. What's the coefficient of x here? It's 1. The coefficient on the left is what? C. So 1 is equal to c. Very nice. So we can continue and find the constant, but I think now we have enough information to find out what's what. Since a is equal to negative 3, we can substitute that over here. We're going to get 18 is equal to negative 3 plus b. And that means b is equal to 21. And we know that 1 is equal to c. So then you can rewrite this as what? A over x, so negative 3 over x. I'm copying this with the letters that we found. Plus bx, b is 21, so 21x. Plus c, c is 1 over x squared plus 4. So this is your partial fraction. Very easy, a bit long. As you can see, you don't have to do all this. As soon as you figure out what b is, just put in the value. You don't have to write anything, okay? Moving on. Question 15. What is the value of b in 7x cubed minus 59x plus 48 over x minus 3x plus 3? Okay, over here, when you have the degree, what's the degree here? The degree here is 3. Okay, but if you look at the degree down, you have x and x, so it's 2. The degree down is 2. So, is the degree up less than the degree down? No. And what is our first condition What's our first condition for partial fraction? The degree of the numerator must be less than the degree of the denominator. In this case, it's not. So what do we do in that case? We do long division. So let's do long division. X minus 3, x plus 3 becomes x squared minus 9. Okay, when you open it up. So let's do long division. 7x cubed minus 59x plus 48. X squared into 7x cubed. What do you multiply x squared to become 7x cubed? You multiply by 7 for the 7, and to make x squared x cubed, we need to multiply by an x. So x squared times 7x is 7x cubed. Minus 9 times 7x is minus 63x. Okay, you're gonna put the minus here and you're gonna continue. This becomes 0. And by the way, if you get confused about distributing the minus, always in long division put the brackets here so you can remember that the minus is going into everything inside here. Minus 59 minus what? Yeah, minus 59 minus 63 is 4x. Okay, 0 plus 4x, and take the 48 down. Okay, now x squared, can you put it into 4x? No, you can. Whoa, that sounds wrong. X squared can't go into 4x, right? You can't like divide it because the degree here is less than this. How you can't go from x squared to 4x? You can only go up, but you can't go down. Okay, so المهم in terms of powers, you can only go up a power, but you can't go down in terms of a power. المهم, you're gonna get that the answer is 7x. This here is the same as 7x plus your remainder 4x plus 48 over x squared minus 9. I'm just gonna write it as the original factored form so we can save time. Okay, so this is your new equation. Type this 7x, we're gonna put it on the side. What are we gonna do now? We're gonna split 4x plus 48 over x minus 3x plus 3. So we know we're gonna split this into a over x minus 3 plus b over x plus 3. Yalla. How do we do it? We know that over here our factors are all linear. None of them are quadratic, so we don't need to have any linear numerators. Adi, they can just be constants. So we're allowed to do what we're doing now. No quadratic factors, so this is easy so far. What's the step now after we split? We have to do what? Form our equation. So yalla. A, here we have x minus 3. What do we need? We need the x plus 3. So we're going to make x plus 3. Now B, you have x plus 3, you need an x minus 3. So x minus 3. This equals what? The old numerator, 4x plus 48. Type. Do we have zeros? Yes, we do. So let's substitute our first 0, which is x equals negative 3. Now, to save time, they want the one of x minus 3. So if you want the one for x minus 3, so they want B, they want my V, they want my... They want my B. So let's take the first 0 to be the 0 that doesn't cancel B out. If I choose my 0 as x equals 3, it's going to cancel B out and I'm going to end up finding A before I find B, which is going to waste a bit of time. So for that reason, since I'm in the exam and I'm trying to save time, I want to find the B, which is the numerator of x minus 3. In this case, my numerator of x minus 3 is... Oh, sorry. I didn't realize that the B here has x minus 3, but my B has x plus 3. See, this is why I tell you, don't follow what they're asking for. Write down your answer and then compare the letters. Never, ever take the letter and then compare it with the answer. No. Always find your final answer, plug your letters into your fractions and see your final fraction and then substitute them, type in your answer. Because they will, most of the time, they're going to be using different letters than you are. Okay, so don't mix yourself up. Solving normally, let's just take any 0. So in this case, I don't want to confuse you and tell you do this before this. Adi, anything works. As long as you write down your answer and plug everything back in normally and then compare, that's completely fine. So let's substitute x as 3 first. Let's 3 or negative 3. They both work. We'll just do negative 3. You're going to get a times 0 plus b into negative 6 equals 4 into negative 3 plus 48. Yalla, this goes minus 6b equals minus 12 plus 48, 36. So you get b is equal to negative 6. Type, you got b is equal to negative 6. Do we have any more zeros that we can try? Yes, we do. We have x equals 3. Substituting x equals 3, we're going to get a times 6 plus b into 0 equals 4 times 6. 4 times 3, sorry, plus 48. So you're going to get 6a equals, this goes, equals 12 plus 48, 60. So that means a is equal to 10. Type, you now have your a value, b value. Do I take b as negative 6? No. See, this is why you're going to get it wrong if you without looking, you just put in your letter value. No, don't do that, okay? After you find your letters and you're ready to answer, before you answer, take a deep breath and substitute your letters back into your original partial fraction. So let's substitute our a value. It's 10 over x minus 3 plus b, which is negative 6 over x plus 3. Okay, and we don't forget we have the 7x on the side. Right? So this is my final answer. Now, Henry, what are they asking? They want b. So does that mean I look at my b here? No. I look here. What's their b? b is the numerator of x minus 3. So what's my numerator of x minus 3 here? It's 10. So please don't make the mistake in putting negative 6 because it would be such a silly mistake. Haram, you get that wrong. Wallah. So now we're done. with the quiz, but we still skipped, I think, 6 questions. We have this one, this one, this one. It's 3, 4, 5, 6, 7. Okay, that's 7 questions. So let's do them now using our partial fraction knowledge. So integral 2 over x minus 1. So if you try to integrate this, you're gonna get 2 over x squared minus x, and you can't do that, okay? Because if you do it, you have the power of -1, and when you integrate it using the rule that we used to do, if you take it up, sorry, this is power 1. So when you take it up, it's gonna be 2x squared minus x to the power of -1. And no matter what you do, if you try using our old method of adding 1 to the power, you're gonna end up with x squared minus x to the power of 0, because when you add, you're gonna get power of 0. We cannot do that. So this whole technique of partial fractions, the only reason we teach you it, and you're going to use it a lot, and you're going to see it not only in integration, it's very nice actually. You're going to see it in a series. If any of you are going to do anything that has to do with calculus AB or BC, you're going to use it in series. If you're doing further math A level, which I doubt anybody is doing, but in uni you're going to use it in series, calculus 2. You're going to use partial fractions in almost every step of math that's sort of advanced, okay? Anyways, let's do it. How do you know you need to do partial fractions? Someone might ask me, why do I need this in my life? Okay, how do aslan? Okay, I'm going to learn this now. I'm going to throw it out the window. Partial fractions, you need it because look at this. When you want to integrate, you need to split it up into 2 things so you're able to integrate it. So how do I know I'm doing partial fractions? You look at your denominator. Does it have roots? Does it have roots? Yes, it does. Okay, that means you should, as soon as you see the root, that means you should start thinking, oh, I need to do partial fractions. Okay, so khalas, here you have your roots, you want to do partial fractions. Let's do partial fractions. I mean, we need to split this up into smaller fractions. Now, with integration, you're not going to see a big, huge partial fraction. Now, it's obviously you might, but I don't think she will give it to you because khalas, you're already taking time to integrate. Why am I going to give you a hard fraction, So let's see. Let's split this up. 2 over x minus 1. أول شيء, the degree up is less than the degree down. That's the first thing. The denominator is fully factored. So we can easily start by splitting. So a over x plus b over x minus 1. There is no quadratic factor, so we don't need to write it as ax plus b or bx plus c. خلاص, this is perfect. Okay, now we form our equation. We know that with this a, it has x. We need an x minus 1. So a into x minus 1 plus b. What does b need? b needs an x. This is all equal to our original numerator, 2. Type. Check your zeros. What are our first 0? X equals 1. You're going to get a into 0 plus b into 1 equals 2. This becomes 0, right? So you're going to get b is equal to 2. Perfect. Type. You checked your first 0. Do I have any other zeros? Yes, I do. Substituting x as 0 will give me another 0. So a into -1 plus b into 0 equals 2. This cancels. This is a 2 here. This cancels, so you're going to get negative a is equal to 2. So a is equal to -2. So over here, we're going to rewrite this as -2 over x plus 2 over x minus 1. So over here, this integral can be rewritten as integral from 2 until 3. Now, if you have an integral calculator, which I doubt, you can just do this on your calculator. But let's not. No, actually, the calculator will give you an exact answer, so you can't do this on your calculator. So from 2 till 3, and we split this up into our partial fraction. Now we can actually integrate -2 over x plus 2 over x minus 1 dx. طيب. يلا. How do you integrate this? We're going to integrate it piece by piece, okay? Forget about this one. We're going to do this first, okay? What's integral of -2 over x? Take the -2 to the side. It becomes integral 1 over x, right? I'm going to rewrite it like this. We're going to take all the 2's to the side. 1 over x minus 1. Here you have dx, and here you have dx. Right? So isn't this the same thing? I took the 2's to the side. Okay? Now, what is integral 1 over x? Isn't it ln x? Yes, it is. So it's -2 ln x. Right? So from 2 until 3. Remember the rule for integral of 1 over x is equal to ln x. And the integral of u prime over u is equal to ln u. These are rules you need to know. If you don't know them, you can't solve. Okay? So integral 1 over x is this. Type. Integral, now plus 2. Integral 1 over x minus 1. Now we know that It's not 1 over x, so we can't say it's ln x. But we know that the derivative of x minus 1 is 1. So we can use the rule u prime over u is equal to ln u. So it's going to be ln u in this case is x minus 1. Okay? And this is also from 2 until 3. So we can kind of simplify this. Factoring the 2 out, we can get it's ln. I'm going to start here because this is a minus. I'm going to say ln x minus 1 minus ln x. Okay, just to make this cleaner from 2 until 3. And we can actually say that since you're minusing lns, remember when you're subtracting lns, you can divide. So it's 2 ln x minus 1 over x from 2 until 3. So we cleaned it up. Now it's time to substitute. I just cleaned it up so it can look neater. It's easier to solve like this. Okay, I'm gonna put this here like this. Okay, so we cleaned it up. Substitute 3, you're gonna get 2 ln 3 minus 1 over 3. And then minus, substitute 2 ln 2 minus 1 over 2. So this is going to become 2 ln 2 over 3 minus 2 ln half. Factoring out the 2, you're going to get ln 2 over 3 minus ln half. And you know, when you subtract lns, what's the rule for ln m minus ln n? It's equal to ln m over n, right? Remember, ln m minus ln n is equal to ln m over n. You divide, right? So that means 2 becomes 2 ln 2 over 3 divided by half is actually it's 4 over 3. So it becomes 2 ln 4 over 3, as you can see here. Now, I think the complex part is just the simplification part. You guys haven't done integrals in a very long time, so this is why I think it's gonna be a bit tricky. Okay, so please remember these rules. They are very important if you need to move forward. Okay, if you want to move forward. Type. Moving on. Question 3. Yeah, question 3. Over here. Oh no, question 3 is not this here. No. 4 maybe. Yeah. Okay. Type. You have integral 7t squared minus 13t plus 2 over t minus 1 squared. So the degree of the numerator is 2 and the degree of the denominator is what? 2. You have 2 here and you have 1 here, so 3. So it's less, so we can proceed with partial fractions. Okay, how do you do this by partial fractions? We're going to split it up. As you can see, also our denominator is already factored. We don't need to factor it ourselves. So it's already factored, so let's do it. It's going to be a over the first factor t plus b over t minus 1 plus c over t minus 1 squared. Someone might tell me, and even you're this far into the recording, you might ask me, why isn't it like this? Always, I tell you, whenever you have something raised to the power of as your roots, that means you have 2 roots, t minus 1 and t minus 1 squared. You keep on going until you complete the power that's here. So if it's at power 5, مثلا if it had power 5, you keep on doing, you do t minus 1, then the next one will be t minus 1 squared, and the third one will be t minus 1 cube, and then t minus 1 4, and then t minus 1 5. You keep on doing it until you reach the power here, okay? So this is how the splitting will look. Then someone might come and ask me, Walid, isn't this a quadratic? Why aren't you writing it as ct plus d? Good question. I told you the only time if it's a quadratic that is not factorable, مثلا something like this, t squared plus 1 or t squared plus 3. These are all quadratics that are not factorable, okay? Not t plus 2 squared. No, this is a factorable quadratic. You can factor it into t plus 2, t plus 2. Okay, so there's a difference. This is a reducible quadratic. The other ones I showed you were irreducible. Okay, anyway, so you did your splitting now. What's the next step? We need to form our equation. How do we form our equation? We have here in our denominator, we have t. So what do we need? We already have the t. We need the t minus 1 squared, right? So you always look at your original denominator. Plus b. b already has a t minus 1. So we need 1 t and we need 1 t minus 1. So b into t minus 1. The c already has t minus 1 squared, so what does it need? Needs a t equals the original numerator 7t squared minus 13t plus 2. Yalla, let's take a look. What are our zeros? Our first zero that I can see here is 1. So let's substitute t equals 1. You're going to get a into 0 plus b into 1 times 0 plus c into 1 equals 7 minus 13 plus 2. So you're going to get that. This gets you 0. This gets you 0. You're going to get c is equal to 9 minus 13, negative 4. Okay, you got c equals negative 4. Type, what's our second zero? Our second zero is, your second zero is t equals 0. Right? T equals 0 will give you a 0. So a into negative 1 squared, plus b into 0, 0 minus 1, plus c into 0 equals 7 into 0 minus 13 into 0 plus 2. So what are you going to get? This cancels. This cancels. So you're going to get a. Negative 1 squared is 1. No? Don't make that mistake of putting it as negative a. It's a equals. There's nothing left on the left. So equals 7 times 0, 0, 0, 2. Type. We finished from our zeros and we finished. We finished from our zeros and we still have one letter left, which is b. We didn't find it. So what do we do if we want to find the letter? We can do comparing coefficients, but I think it would be faster to substitute any value that you want. Now, the substituting any value you want actually works every single time, but the reason why I tell you to do comparing coefficients is because comparing coefficients is way faster than substituting values, because substituting values takes time, because you would have 4 unknowns and you would have to find like 5-6 different equations, which takes you a long time. But if you have all your letters and you only need one left, you can do comparing coefficients, it's fine. But it would be faster to do trial and error. Okay, not trial and error. It would be faster to just substitute one of your values, because you only have one unknown left, and that's in this case b. So let's substitute everything back into our equation here. We know a is 2, so 2 into t minus 1 squared plus b, we don't know what it is, we're still trying to figure it out, plus c, we know it's negative 4, so negative 4t equals 7t squared minus 13t plus 2. As you can see here, we only have one unknown left, and in this case you can just choose any value of t that you want. Okay, so choosing any value of t, let's choose we already chose 1 and 0, but let's just choose 2 as our value of t. So 2 into 2 minus 1 squared, so 1 squared, plus b into 2 times 2 minus 1 plus, oh no, it's minus 4 into 2, right, t equals 2. 4 into 2 equals 7 times 2 squared minus 13 into 2 plus 2. So you're gonna get 4 plus, okay, let me do the constants first. This is sorry, let me do the b first. This is 2b. Here you get negative 8. Here you get 2 minus 8 is negative 6, so minus 6 equals, here you have 28 minus 26, that's 2 plus 2, 4, so you get b is equal to 5. Type, we now have a, b, and c. Can we go back to our partial fraction? Yes, we can. So now we can finally integrate, because we know what a, b, and c is. So a is 2, so 2 over t, plus b, which we know is 5 over t minus 1, plus c, which is, we know, is minus 4, so minus 4 over t minus 1 squared. So, can we integrate now? Yes, we can. I'm going to choose all the space on the top here as my integral. Let's integrate. So, we need to integrate 2 over t plus 5 over t minus 1 plus, alright, let's do minus 4 over t minus 1 squared. Yeah, dt. Type. First integral, 2 over t. خلاص, memorize it إنه any constant k over t or over x, integral k over x dx is just k ln x. Why is it k ln x? We know that without the k, if it was 1 over x, it would just be ln x. But since you're multiplying by that k, we're adding that k ln x. Okay, so خلاص, be quick with it. Okay, I don't want to explain every time. Take the 2 out, and then 2 times 1 over t is 2 ln t. Okay, خلاص, 2, take the 2 to the side, it would be 1 over t, it would be, that means it's ln t. But since you have the 2, it becomes 2 ln t. So you have 2 ln t. 5 over t minus 1, using the rule. Remember, there's 2 rules that you're always going to use. This and this. U prime over u is equal to ln u. Okay, in this case, taking the 5 to the side, we're going to take that as a constant. You'd have 1 left now. Okay, what's the derivative of t minus 1? Isn't it just 1? Yes, it is. So that means the derivative of t minus 1 is the one on top. So that means we can use the rule u prime over u, and it's going to be ln t minus 1. Again, why is it 5 ln t minus 1? I had to cut the video. Why is it 5 ln t minus 1? Because, like I said, using the rule, it's 5. Hold up, it's 5 over t minus 1, صح? So this is u prime over u using this rule. So integrating 5 over t minus 1 is ln t minus 1, but since you have the 5, it becomes 5 ln t minus 1, okay? So like we did here. Okay, then the integral of minus 4 over t minus 1 squared dt, this one here, what's left over, we finished this, we're left with this one here. Okay, how do you integrate this? Everybody should know how to integrate this. You take the t minus 1 up, it's like how we used to do, okay, and then add 1 to the power, it becomes negative 1, and divide by the new power, this becomes positive, and this goes down, so it becomes 4 over t minus 1. So plus 4 over t minus 1. Now, is this the correct way to integrate this? Yes and no at the same time. Because remember, if you have more than one thing under the power, you need to use u substitution. You have to say u is equal to t minus 1, then du is equal to, what's the derivative of t minus 1? It's just 1, so it's equal to 1 dt. So since they're equal, you don't have to do this stuff. Like, since the derivative of t minus 1 is just 1, you don't have to do u substitution. But if it was مثلا 2t minus 1, then the derivative would be 2, and you have to substitute dt is equal to du over 2, and then go back here and substitute it. It would be minus 4 over u to the power of 2. dt is du over 2. And then you have to integrate it, and it would be, this cancels with this. You're going to get minus 2 u to the negative 2 du. Integrating this, you get minus 2 over u. 2 over u, you get 2 over u. Okay? That's if it was 2t minus 1, but in this case it's not. I just had to show you, just in case you guys forgot how to integrate. Okay, in case you forgot how to integrate, and why is my هيدا lagging. فالمهم, what I did now, ignore that. What you need is what I did here. T minus 1, take it up, becomes negative 2. Everyone knows how to integrate this at this point. Okay, and obviously you can't forget your constant. So this is your integral. Let's see, can we simplify anything? No. 2 ln t plus 5 ln t minus 1 plus 4 over t minus 1, as you can see, 4 over t minus 1 plus c. Question 5. This one here. Okay, so you have an integral and you have factors down, so obviously we have to use partial fractions. Okay, anytime you have factors, you need to use partial fractions. Let me just restart my software because it's very laggy. Okay, we need to use partial fractions. Let's take a look. The first thing is to do partial fractions, right? So 7t squared minus 8t over t plus 3. You know, I'm not going to rewrite it, so I save some space. Over here, first thing to do when doing partial fractions is check the degree, right? Degree up is 2, degree down is, you have t here and t squared, so that means you have 3. The degree down is 3. Type, is the degree up less than the degree down? Yes, it is. So can we do partial fractions? Yes, we can proceed. Yeah, let's proceed with partial fractions. Let's start. أول شيء, check that your denominator is fully factored. Is this fully factored? Before we proceed, t squared minus 4t plus 8, I have a small feeling it's not factored, but let's take a look. T squared minus 4t plus 8, it is fully factored because, as you can see, I got an imaginary number. Okay, in the exam, if you don't have equation mode, to check whether a quadratic can be factored, find the discriminant delta. Okay, isn't delta b squared minus 4ac? If b squared minus 4ac is negative, then it can't be factored. Okay, so over here, just like to apply that example here, b squared is going to be 16 minus 4 times 1 times 8. You get negative 16, which is a negative number. So since delta is negative, that means it's fully factored. You can't factor it again. Okay, المهم, moving on. Since our denominator is fully factored, we can proceed with partial fractions. So we're going to split this up into two factors. A over t plus 3 plus b over t squared minus 4t plus 8. But Walid, isn't this a quadratic? Yes, it is. So can I just say b? No, I need to say bt plus c. Okay? Many times we repeated this. If your factor is a quadratic that cannot be further factored, your numerator has to be bt plus c. Or it has to be a linear function. Anyways, so this is our fractions, we should now form our equation, right? Let's form our equation. What do we need here in our denominator? We need to look like this. We need t squared minus 40 plus 8. So a to t squared minus 40 plus 8 plus this here bt plus c. What do we need? We need a t plus 3, right? So let's multiply by t plus 3, right? We have this here. We just need a t plus 3. Okay, so once we multiply them, this should all be equal into what? Our original numerator, right? This is the rule. 70 squared minus 80. طيب, we did it now. What do? Let's check our zeros. We should start solving, right? So this one here, since it can't be factored, there's no zero. It can't be zero. If it can't be factored, then it will never be zero. So we're gonna skip this for our zeros. We're gonna here take t plus 3. What's the zero of t plus 3? Negative 3. So let's start with our first zero. T equals negative 3. So a into negative 3 squared, which is just 9 minus 4 into negative 3 plus 8 plus b into negative 3 plus negative 3 all multiplied by negative 3 plus 3, which is 0, but we're going to keep it like that, to 7 times 9 minus 8 times negative 3. Why did I say 9 here and here? Because it's square. Okay, negative 3 squared is just 9. Okay, let's cancel. This negative 3 plus 3 gets you 0. Okay, over here you have 9 plus 12, which is 21, plus 8 is 29. So 29a equals 63 plus 24, so that's 87. So you should get, when you divide by 29 both sides, that's 3, if I'm not wrong. 29 times 3, is that 87? Yes, it is. Okay, so you get a is equal to 3. Nice. طيب, you know a is equal to 3. Is there any other zeros I can test over here? Check. There's no other zeros over here, right? Here we don't have a 0, and here the 0 is negative 3, which we did already. Someone's going to tell me, why don't you use t as 0? If t as 0 is not over here on the letter side, I can't use it, okay? Someone's going to say, oh, t is alone, so you can use t as 0. No, you can't. Since that t is not part of our letter side, okay? ما تتفلسف. It should be a coefficient of one of the letters. Anyways, so we're done with our zeros. So what do we do if we're done with our zeros and we still have letters that we haven't found? We have to compare coefficients. Let's compare coefficients. Let's start. On the right side, let's compare the t squared coefficient first. The t squared coefficient on the right is 7. Like I said, to make our lives easier, I'm going to expand the left-hand side fully so that you're not confused with the coefficients, okay? So here it's going to be at squared minus 4at plus 8a. And over here you have bt squared plus 3bt plus 3ct. Sorry, what? No, plus 3bt, and then you have plus ct. C times c is just ct plus 3c. Okay, this is expanding the left-hand side fully so that you can see the coefficients clearly. This is what I told you before. You can do it directly in your head, but some people work better when it's on paper. And in my opinion, it's best that you write it on paper because it makes sure if you have time, this makes sure that you get nothing wrong. It makes sure you see everything properly. So on the right side, our coefficient of t squared is 7. But on the left-hand side, our coefficients of t squared are a and b. So a plus b. Okay, so this is our first equation. We know that, we're going to keep it for the end. On the right-hand side, what's the coefficient of t? It's negative 8. On the left side, the coefficient of t is 4a. Sorry, negative 4a. And you have you have this, 3b. And you have the c. So this is our second equation. Now, what do we know? We know a is 3. So plugging in a as 3 here will get you b equals 4. Right? So 7 is equal to 3 plus b. So b is equal to 4. Now, you know what a is, you know what b is. So we can solve this, right? So negative 8 is equal to negative 4 times a, which is 3, plus 3 times b, which is 4, plus c. So you get that c is equal to, this cancel, you're going to get c is equal to negative 8. So you found a, b, and c. So can we go back to our partial fraction now and start integrating? Yes, we can. Let's continue our integration. I'm going to integrate in this box here. But first, I'm going to rewrite my partial fraction. Now, with our values of a, b, and c, I'm going to take this down over here. A is 3, so 3 over t plus 3. B and c are what? 4, so 4t plus c, which is negative 8. So let me just put a minus. minus 8 over t squared minus 4t plus 8. So we did our splitting, we did our partial fraction properly. Now, let's integrate. So integral 3 over t plus 3 plus 4t minus 8 over t squared minus 4t plus 8. طيب, over here, the first integral is very easy. If you take all the time, whenever you see an integral like this, look at the bottom one and derive it. Try deriving it. What do you get? You get 1. But oh, you have 3 at the top. So what do? We move the 3 to the side. We take it out. Okay, and becomes 1 over t plus 3. And what's the rule for this? Remember, integral u prime over u. It's just ln u, right? Since the derivative of the denominator is the numerator, that means the first integral is going to be 3 ln t plus 3. Okay, nice. So obviously don't do it like how I did in the exam, but think of it like this. What's the derivative of the bottom one? Sorry. What's the derivative of the bottom one? It's 1, but I have a 3 up top, so that means I have to multiply my answer by 3. Okay, very easy. Plus, now the second integral is a bit tricky. Okay, what is the derivative of this? It's going to be 2t minus 4, right? Now, if you take a look, this is why I tell you, always ask yourself what's the derivative. The first question you ask yourself, what's the derivative? It's 2t minus 4, right? Now over here I have 4t minus 8. Can I make this 4t minus 8 look like 2t minus 4? Yes, I can. If I factor out the 2 outside, it's going to be 2t minus 4. So this is the same thing as what we had here. It's the same thing, but it's just multiplied by 2. So what does that mean I have to do to my answer? I have to multiply it by 2. So isn't the numerator now, let me just rewrite this so you can kind of understand it. The numerator is 2 into 2t minus 4, right? Type, there you go. It was 4t minus 8, I just rewrote it. And the derivative of this is 2t minus 4. So isn't this, again, u prime over u? Yes, so we can just do ln of the denominator, t squared minus 4t plus 8. But what do you have to do? Multiply by 2. Why? Because here we have that 2 here. Same way how we had to multiply by 3 here, you have to multiply by 2 here. Okay? Same thing. So this is your integral, and you can't forget your constant of integration. So 3 and 2. Perfect. Question 6. You have, is this the last one? Oof, we still have 3. Oof. Okay, over here. I just had to scroll down. Okay, this is a bit easier. Okay, 29x minus 18 over x minus 1. So obviously, since you have factors, you need to do partial fractions. So numerator up, the degree is 1, degree down is 2, so it's less, so we can proceed. Denominator is fully factored, so we can proceed. So everything's there, we just need to start splitting. So we're going to get something over x and something over x minus 1. And it's both linear, they're both constants at the top, since here we only have linear terms. We don't have any quadratic. Okay, so we have this. Type, let's form our equation. How do we form our equation? We need to multiply a by, what do we need here to complete the denominator? X minus 1. Then multiply b by what? What do we need? We need an x, right? Compare it with your original denominator. We need to multiply it by x. Equals our original numerator. Now, what do? We check for our zeros. Here we have 2 zeros, so this should be a very easy partial fraction decomposition. Our first 0 we're going to take as 1. So a into 0 plus b times 1. I'm writing it as 0 because 1 minus 1 is just going to be 0. Equals 29 minus 18. So you're going to cancel this. So you're going to get b is equal to, عندك شو قد هيك 11. حلو. طيب. Checking your next 0 would be x equals 0. A times 0 minus 1 plus b times 0 equals 29 times 0 minus 18. So this gets cancelled, this gets cancelled. So you get negative a is equal to negative 18. So a is equal to 18. Type. Over here, since you have your a and b value, we can go back to our partial fraction and plug that back in, right? So now we're going to do integral a over x. So integral a over 18 over x plus 11 over x minus 1 dx. And don't forget your bounds are from 2 until 4, just so you don't forget that in the exam. Type, perfect. Okay, let's solve this. Very easy. This is a way easier integral than the before. So 18 over x, same thing as before. What's the derivative of x? It's just 1. But what I have up here, it's 18. So since the derivative what sorry the derivative of the denominator is 1, right? But you have 18 up, so that means I multiplied by 18. So in my answer I should multiply by 18. This is 18 times 1, right? It's 18 times the derivative, so that means I should multiply 18 here by my answer. What's the derivative? What's the integral of 1 over x? Ln x, right? I'm applying this rule, u prime over u. If you want to make it a bit more simpler, if you don't understand why I'm multiplying, use this rule. Ku prime over u is equal to k ln u. Okay, obviously plus c. Ln u plus c. Okay, المهم, you want to follow this rule, follow it. Type, so you get 18 ln x for your first one. Over here, what's the derivative of x minus 1? Again, it's 1. Here I have 11 times 1, so I'm going to do 11 ln x minus 1. So 11 ln x minus 1. This is just a rule. I'm not getting anything from myself. Now, I don't put plus c because it's in between bounds 2 and 4. So it's going to be 18 ln 4 plus 11 ln 4 minus 1 minus 18 ln 2 plus 11 brackets 11 ln 2 minus 1. Let's clean this up a bit. We're going to get over here 18 ln 4 minus 18 ln 2. We can factor out, okay, when you expand this all, you're going to get 18 ln 4 plus 11 ln 3 minus 18 ln 2 minus 11 ln 1. Okay, if you don't know yet, ln 1 is 0. Okay, so you're left with this here, 18 ln 4 plus 11 ln 3 minus 18 ln 2. Okay, you can factor out the 18 and 18. You're going to get 18 ln 4 minus ln 2 plus 11 ln 3. طيب, over here we know when you subtract lns, that means you just divide. So 18 ln 4 over 2 plus 11 ln 3. So that means, what's ln 4 divided by 2? What's 4 divided by 2? It's 2. So 18 ln 2 plus 11 ln 3. There you go. I think last question. One more. Two more. Hello. Okay. Integral 60x squared plus 50x plus 46. Okay. And, ooh. I don't think you learned the tan inverse integral. So, I'm just going to make sure of this. So, for this question, you need to know, I don't know, nobody's really talking to me right now, and I wasn't attending class, but integral of 1 over x squared plus 1, you need to know is tan inverse x plus c. Okay, in case it comes, I don't know if it's in the quiz, maybe the teacher said it's not coming, don't do it, but I wasn't in class and nobody told me anything. Okay, so I'm going to continue as if, خلاص, it's coming. Okay, but you need to know this rule. It's a rule, actually. It's nothing you should know. It's a rule. Okay, so over here we want to integrate. The degree up is 2 and the degree down is 1, 2, so you have 3. Okay, so since it's less, we can continue, and since these are completely factored, عادي, we can continue. Let's move on. Let's start with our splitting. We'll proceed. So we're going to split into a over x plus 1, and then plus, over here you have a quadratic factor. So since it's a quadratic factor, can I just put b? No, I have to put bx plus c. Type, let's start, form our equation. We're going to multiply a. What do we need here? We need x squared plus 1. So a into x squared plus 1. What does this bx plus c need? It needs an x plus 1, right? This equals the old numerator. And we can start our solving. Do we have any zeros? Here, the x squared plus 1 can never be 0. But the x plus 1, we have a 0, which is negative 1, right? So a into negative 1 squared, which is just 1, sorry. A into negative 1 squared is 1, so 1 plus 1, plus bx plus c. Bx, we said, is negative 1, so negative 1, plus c, multiplied by negative 1 plus 1 is 0, equals 60 times 1, because negative 1 squared is 1, plus 50 times negative 1 plus 46. We're going to get that 2a, this cancels all of this because it's multiplied by 0, equals 10 plus 46, 56. So you get a is equal to 28. Now there's no more zeros, and we still have 2 letters to find. So what do? We have to compare coefficients, right? So compare coefficients. Yeah, let's compare coefficients. How do you compare the coefficients? Let's take a look. On the right side, you know what, let's expand, just so you guys don't get confused. So you get here, when you expand ax squared plus a, over here when you expand, you get bx squared plus bx plus cx plus 1 This is the left side, okay? Just so you don't get confused with what's the coefficient of what. So let's start with the coefficient of x squared, comparing coefficients. Comparing the x squared coefficient on the right, it's 60. On the left, it's what? It's a and b, so a plus b. Ax squared and bx squared, you see them? Okay, let me just put a box around this. We're going to call this equation 1. Now let's take a look at the x, comparing the coefficient of x. On the right, you have a 50. On the left, you have b and c. So b plus c. We're going to call this equation 2. Now you can go to the constant term, but I found everything I need. Since I already know what a is, I can find b. And then, since I would have found b, I can find c. So let's first find b. 60 is equal to 28 plus b, since we found a already. So b is equal to 32. And then, since b is 32, c is equal to, you're going to get that it's equal to 18. Okay, so our new partial fraction will be, let's fix it here, a, which is 28 over x plus 1, plus bx plus c, so b is 32, 32x plus c, which is 18, over x squared plus 1. So this is our new partial fraction. Let's now integrate. So integral of our partial fractions, 28 over x plus 1, plus 32x plus 18 over x squared plus 1 dx. Okay, now to integrate, very easy. What's the derivative of x plus 1? Derivative of x plus 1 is what? 1. Up here we have 28 times 1. So that means we have the derivative, so we just need to multiply by 28. So it's going to be 28 ln x plus 1. Okay, let me continue. Now, this one here is a bit tricky. Over here, you want to take a look at the derivative. You're going to get 2x, right? Now, over here, I don't have 2x. I have 32x plus 18. But here, when you have, if you remember, when you used to have 7x plus 3x squared over, it was 2x, they'd ask us to integrate this. What did we used to do? We used to split this up into two fractions. This is the same as 7x over 2x plus 3x squared over 2x, right? And we used to integrate it like this. Now, here, you're going to do the exact same thing, okay? Over here, 32x plus 18. I'm going to split it into two fractions. So I'm just going to put this on the side. I'm going to integrate this now on the side, okay? Integral 32x plus 18 over x squared plus 1. Now, what you're going to do is you're going to dx. You're going to split this into two fractions. 32x over x squared plus 1 plus 18 over x squared plus 1. You're going to integrate it like this. Now, this is extremely easy to integrate. Now, we said x squared plus 1 is what? The derivative of it is 2x. Over here we have 32x. But 32x is just 2x times 16. Right? So I have the derivative, so I need to multiply it by 16. So very easy. What are we going to do for the first integral? For the first part, we're going to do 16. Since we're multiplying it by 16, we have to multiply our answer by 16. So 16 ln x squared plus 1. Using this rule, integral u prime over u, and the one I've been using for every question until now. Okay? And sorry, ku prime over u equals k ln u. Okay? Using this rule. Right. So we did the first one. Now the second one is using this rule over here. We said 1 over x squared plus 1 is equal to tan inverse x plus c, right? So this here, the integral is just going to be tan inverse. So as you can see here we in the rule we have 1 over, here we have 18 over. But we said 18 is just the same as 18 times 1. So we're just going to multiply our answer by 18. So we're going to say plus 18 times the rule. What's the rule? Tan inverse x. Okay? And obviously we can't forget our c. So let's combine everything together. So we're going to get 28 ln x plus 1 plus 16 ln x squared plus 1 plus 18 tan inverse x plus c. This is your solved integral. Okay, so you have 28 for x plus 1, you have 18 for tan inverse, and you have 16 over here for the ln x squared plus 1. Type. Question 8. Okay, this is the last question that I'm going to be recording since we did everything else. Where did I go? 8. Integral 10x squared minus 5x plus 6 over x squared x plus 1. First thing we have to do is split into partial fractions because we have factors at the bottom. It's factored, right? So how do we split into partial fractions? Check the degree. Up the degree is 2. Down the degree is 3. Perfect. Okay, so you want to now proceed But first you have to check, obviously, is your denominator fully factored? In this case, yes, it is. So since we saw that it is fully factored and the degree is smaller, let's proceed with partial fraction. So we're going to have, we have how many factors? Not 2, we have 3. How do we have 3 factors? Because x squared is x and x squared at the same time. Then you have x plus 1. Okay, so it's 3 factors. Please don't mess this up. It's a very common mistake. So a over x plus b over x squared plus c over x plus 1. Someone's going to come and ask me, what do you do? This is quadratic. Why aren't you doing bx plus c? Like I said before, many times, it's not a quadratic. It's a full term raised to the power of 2. Okay? Type. If it was x squared plus 1, then it would have been a quadratic and you'd have to do bx plus c. Type. Moving on. We found our partial fractions. Now it's time to form our equation, right? So let's form our equation. A, we already have x. What do we need? We need another x, and we need an x plus 1. So we're going to multiply it by x plus 1. B, we already have x squared. What do we need to complete this denominator? We need an x plus 1. So multiply it by x plus 1. The c, we already have the x plus 1. What do we need? We need an x squared, right? So x squared. Okay, this is all equal to our old denominator, 10x squared minus 5x plus 6. So you have this over here. Type. What's the first thing we do when finding our letters? Test your zeros, right? What are our zeros? Let's start with the most obvious one, x equals 0. Okay, so you're gonna get when x is equal to 0, we're gonna have a times 0. I'm not gonna continue writing it, plus b times 0 plus 1 plus c times 0 equals 10 times 0 minus 5 times 0 plus 6. Now cancel. So b is equal to 6. Okay, nice and easy. Type. Do we have any other zeros? As you can see over here, we have another 0. X plus 1. What's the 0 for x plus 1? It's negative 1, right? So x is equal to negative 1. So we're going to multiply a. I'm just going to say it's 0 because this is going to be 0. I don't want to write it all. And then b is going to be multiplied by 0 because this becomes 0. Negative 1 plus 1 is 0. Plus c into negative 1 squared is just 1. Right? So equals 10 times 1 minus 5 times negative 1 plus 6. Again, why I wrote 1 instead of negative 1 is because they're squaring. Okay? So cancel. You're gonna get c is equal to 10 plus 5 is 15 plus 6, which is 21. So c is equal to 21. Type. You have b, you have c, but there's no more zeros that you can test out. What do? You ask yourself, is there a lot of letters left? We only have one letter left. So is it necessary to go and do comparing coefficients? No need. Since we only have one letter left, we choose any value of x that we want and solve accordingly. But you substitute in the letters that you found. So we need to find a. So we don't know what a is. So we know a times x plus 1. Plus b, which we know is now 6. B, which we know now is 6. We're going to put that in here. 6 into x plus 1. Plus c, which we know is 21. So 21x squared equals 10x squared minus 5x plus 6. Substituting in our value of x, any value of x that you want, and you can find what a is. Let's choose an easy value. We put 0, we put negative 1. Let's choose 1. Okay, substituting x equals 1. You're going to get a times 1 times 2. So 2a, right? A times 2 is 2a. Plus 6 times 2, which is 12. Plus 21 times 1 squared, which is 21. Equals 10 minus 5 plus 6. So you get 2a is equal to 12 plus 21 is 33, sorry. Then you have 10 minus 5 is 5, plus 6 is 11. 11 minus 33 is negative 22. So you get 2a is equal to negative 22. So a is equal to negative 11. Now we found our partial fraction. I'm just going to write the partial fraction over here. Found our values for a, b, and c. So over here, a we know is now negative 11. So it's going to be integral from 2 until 3, negative 11 over x, plus b, which is 6, so 6 over x squared, plus c over x plus 1, so 21 over x plus 1 dx. Type. Nice and easy. We can now integrate this. Let's start with our integral here. What's negative 11 over x? Isn't negative 11? What's the derivative of x? It's 1. Up here, I have negative 11 times 1, so I just multiply by answer by negative 11. So negative 11 times, what's the integral of 1 over x? Ln x. Plus 6 over x squared. What's the derivative of... Oh no, you don't even do the derivative of x squared. You get 2x. As you can see, there's no x term up. So we're just going to have to integrate this normally. How do you do integral 6 over x squared? This is an easy one, right? This is the same as saying integral 6x to the negative 2. and then you can just do add 1 to the power and divide by the new power, so it becomes negative 6 over x, right? Why negative 6? Because divide by negative 1, and why over x? Because the negative power goes down, okay? So minus negative 6, yani negative 6 over x. Okay, plus 21 over x plus 1. What's the derivative of x plus 1? It's 1. What do I have up? I have 21 times 1. So what does that mean? The integral of that's going to be 21 times, what's the integral of 1 over x plus 1? Ln x plus 1. Right? So it's 21 times the integral of 1 over x plus 1. And the integral of 1 over x plus 1 is just ln x plus 1. Again, why? Because you're using the u rule. U prime over u is equal to ln u prime. And let's just put k. K u prime over u is k ln u prime. Type. What? No, not ln u prime. Sorry. Integral u prime over u is equal to ln u, مش ln u prime. Okay? But if you want to add a k here, you're going to put the k here. Type. You're done here. ماشي. Nice and easy. What am I going to do now? Yeah, so we found the integral of everything. We don't need to put plus c since we have a definite integral from 2 until 3. So let's substitute our values now. I'm going to just draw a line here. Separate. Let's put the 2 arrows and let's continue. Type. Substituting 3, you're going to get minus 11 ln 3 minus 6 over 3 plus 21 ln 3 plus 1, I'm just going to write it as 4, minus open brackets minus 11 ln 2 minus 6 over 2 plus 21 ln 3, because 2 plus 1 is 3, huh? Substituting 2. Okay, let's clean everything up. I'm going to substitute the minus in, becomes a minus. So this minus plus, and this becomes minus. Okay, type. Let's factor the 11s out. You're going to get 11 into ln 2 minus ln 3. Why ln 2 minus ln 3? Because 11 ln 2 and minus 11 ln 3, right? I like putting the minus after. Okay, so 11 ln 2 minus ln 3. Okay, this minus 6 over 3 is minus 2. And then 21 ln 4. Okay, and then this 6 over 2 becomes 3. And then minus 21 ln 3. Type, let's clean this up again. What can we clean? Now, looking at this here, you can continue simplifying, but I'm trying to look at the answer, and the way they want it is weird. So I'm just going to erase that last step that I did here, which is completely fine, عادي. And I'm gonna keep this here. Okay, so what do they want is, see, when you get to this stage, usually I simplify عكيفي, but this is how they want it. They want it to be ln 2 and ln 3. Now someone might ask me, طب I have ln 4, where did it go? Remember, ln 4 is the same as saying ln 2 squared, right? And since it's ln, if you have a power, where do you take that power? You take it outside and you multiply it. So it becomes minus 11 ln 3 minus 6 over 3. I'm just going to write the minus 6 over 3 as a 2 because it's pissing me off. Minus 2 plus 21 times 2, which is what? 42 ln 2 plus 11 ln 2 plus هاي 6 over 2 كمان هنكتبها as a 3, and then هاي minus 21 ln 3. So as you can see here, we now have ln 2 and ln 3. They're all grouped up together. So let's put the ln 3's together. Minus 11 ln 3 minus 21 ln 3 becomes minus 32 ln 3. Yeah? And then 42 ln 2 plus 11 ln 2 becomes 53 ln 2. So we're done. And then minus 2 plus 3 is 1. So you're left with this over here. 53 ln 2 minus 32 ln 3 plus 1. That's it. Thank you so much for watching, and good luck in your exam.